All right. Number one, suppose two events A and B are mutually exclusive. So mutually exclusives mean they cannot happen at the same time. So if I'm like the probability of me drawing a heart and drawing a spade is mutually exclusive. So I can't draw a card that's a heart and a spade. By working through the following steps, you'll see why two mutually exclusive events are not independent. All right. For mutually exclusive events, can event A occur if B has already occurred? So if I've already drawn a heart, can I also draw a spade? So if I've drawn a heart, could I also draw a spade? No. So I've already know that I've already drawn a heart, I can't also draw a spade. Okay, I don't know if you play cards, so that would be no. So what's the value of P of A given B? So I've drawn a heart. So let's say I've drawn a heart. Let's say event B is a heart. I've drawn a heart. What's probably that card's also a spade? If I know it's a heart, what's probably it's also a spade? None. There's not possible. So it's zero. It'd be impossible. So using the events from part A, can you conclude that A and B are not independent if they're mutually exclusive? Okay. And so the probability of drawing a heart or a spade would be one or 1 out of 4, right? The probability of drawing given it's a heart, also being a spade is 0. So does 1/4 equal 0? No. So they know the two events, they would not be independent. Okay. No, because where's my, they're not independent. I'm sorry, I misread the question. Yes, can you conclude they're not independent? I misread the question. Yes, because they're not independent. Okay, 2 gets tricky. 2 gets a little tricky here. I mess up on 2. All right. So consider the following events that a college student selected at random. Event A is a student is female. Event B is a student's majoring in business. What's probably the student is male or majoring in business? So male, we call that the so that is called the complement of event A. That's the complement of event A. So what you'll do there is you'll put an AC. So if it's a male, it's going to have an AC because it's the complement of being female. And then majoring in business. So or means we're going to do and or. We're going to have the or word and then as the word, and then majoring in business is event B. So it's the complement of event A. Complement of being a female is a male, or they major in business. Okay. The probability that a female, now this is tricky. This is tricky. I get tricked on these. The probability that a female student's majoring in business. So we are given that they are a female. So when we're given that they're a female, we're going to use the conditional probability. And the female event A is going to be on the right side of the vertical segment. Okay. And then given event A, what's the probability they've also majored in business? So that would be event B. So maybe the probability B given A. Okay. The probability that a business major is female. So the probability that business major and female. So this is backwards. So we had before here the event was given they're female. Now what's going to go on the right side of the bar? Their business major. What's going to go on the right side? It'll be B. Okay, B goes on the right side because it's given they're a business major. How many of them are also female? So it'd be A given B. So given their business major, how many of them are female? So A given B. The probability that a student is female and not majoring in business. So female and, so you use the and on this one. So we're going to use and's our word. So it's down to these two. Female is event A. Not majoring in business would be what? Would that be B for business or the complement of majoring in business? The complement. So it's and it's the complement. The probability that the student is a female and is majoring in business. So and's our keyword. They're female and they're majoring in business. So event A is a female, event B is majoring in business, and it says and, so that would be my answer there. All right. All right. Let's look at number 3. M&M plain candies come in various colors. According to M&M Mars Department of Consumer Affairs, distribution of colors for plain M&Ms, and we're going to have different numbers here. Find the probability of a green or a blue. And I believe they want you to put this as a decimal. They might accept a percent. So green or blue, what's the key word? What operation do you think of when you think of or? It's what? Addition. So I want green or blue. So I'm adding up my green and blue. So 8% plus 10% is 18%. I'm going to put 0.018. Okay. So it's 18%. So I'm going to put 0.18. Are the outcomes mutually exclusive? Remember, mutually exclusive means they cannot happen at the same time. Can you get an M&M that's a green and blue at the same time? No. So choosing a green and blue M&M is not possible. So it's no, because it's not. Or are they mutually exclusive? Yes, because I'm sorry. Yes, because choosing a green and blue is not possible. So it's yes, because it can't happen at the same time. So if they cannot happen at the same time, they're mutually exclusive. I apologize. Okay. Find the probability of a yellow candy or a red candy. So what operation do we do here for or? Addition, so yellow plus red. For me, it's 20% plus 17%. That'd be 37%. So I'm going to put 0.37. Okay. Are those mutually exclusive? Can you get a yellow and a red at the same time? No. So they are mutually exclusive because you can't get a yellow and a red at the same time. Okay. Lastly, we want to find the probability it's not purple. So not purple. 20% of mine are purple. How many are not purple? 80%. Yeah, you could just do 100% minus 20%. That's called working with the complements, which would be 80%, which would be 0.8. You could also add up all these outcomes because we know all values in the sample space have to add up to 100% or 1. So you could just add up these outcomes, or you could just do 100% minus 20%, or 1 minus 0.2, so it'd be 0.8. Okay, and so that's your there. It's called working with the complements. All right. Yeah. All right, number 4. Now, I'm going to go back to my notes on this one. You roll 2 fair die. Okay, I'm going to be a little lazy here. Remember on my notes, I established the sample space of rolling a die. You roll 2 fair die, 1 green one and 1 red one. So we could see, I've got the sample space right there. What's the probability of getting a sum of a 6? So mine says a sum of a 6. So I'm going to count the number of 6s. 2, 3, 4, 5. I've got 5 6s over 36 total. So I'm going to enter as a fraction. So it'd be 5 divided by 36. Now, I do not know if you have to reduce the fraction. That won't reduce. I don't know if you have to reduce your fractions or not. What's the probability of getting a sum of a 4? So getting a sum of a 4. Okay, so getting a sum of a 4. So a sum of a 4 would be 1, 2, 3. 3 divided by 36. Now, you can make that 1/12 if you want. Okay. I'm going to see if they accept the unreduced fraction okay. So you had 3 4s out of 36 total. What's probably getting a sum of a 6 or a 4. So a 6 or a 4, or keyword is addition. So you're going to add these up. So you're just going to add these up. So I had 5 6s, 3 4s, 5 plus 6 is 8. So 8 divided by 36. Are these outcomes mutually exclusive? Okay. Can you get a sum of a 6 and a sum of a 4 at the same time? No. So they are mutually exclusive because they cannot happen at the same time. You can't get a sum of a 6 and a sum of a 4 at the same time. I'm going to see if they accept the unreduced fraction. I'm just doing this to check. Like normally I would reduce those, but they do accept the unreduced fraction. Okay. They did accept the unreduced fraction. So, all right. Let's look at 5. Now, we might not be super familiar with a playing card set. Okay, you draw 2 cards from a deck of 52 cards without replacing the first one before drawing the second. Are the outcomes of the 2 cards independent? So let's think about this. If I draw a 3 of clubs, would that have an impact, and I don't put it back in the deck, would that have an impact on what my probability would be for the next card if I take one out? Yes, it does, because I'm not putting it back in there. Good. So these are not independent because the probability of drawing a specific second card depends on the identity of the first card. So if I'm wanting to know the probability of getting a club, it's going to be impacted by whether that first card was a club or not. Okay. So what's the probability of getting a 3 on the first card and 10 on the second? Okay. So I've got a deck of playing cards. I'll write down this paper. So on a deck of playing cards, I've got 2 separate events going on here. Okay, 2 separate events. Okay, a 3 on the first card. How many 3s are there in a deck of cards? 4. How many total cards are there in a deck of cards? 52. Okay, so there's 3. So this is the probability of getting a 3 here. Okay, now when I draw that 3 out of the deck, how many cards are left? 51. Out of those 51 cards. Now, the second event needs to be a 10. What's probably getting a 10 on that second one? 4. Good. And so these are two, we're going to use the general multiplication rule. These are two separate events here. They're not independent because this depends on that. We're going to multiply. So multiply across 4 times 4, 16, and then 52 times 51. Now, you don't have to reduce this, I don't think. That can reduce, but you could just leave it like this. If they don't accept it, we'll reduce it. Okay, that we could talk. You could reduce it 16 to about 2,562 or 2652. I said that backwards. I could do math enter, and then be 4 over 663. So you could also do the reduced fraction, but should take the unreduced. What about a 10 on the first and a 3 on the second? So this time I want a 10 on the first and a 3 on the second. What's probably getting a 10 on the first? How many of your 10s are there in the deck? 4. How many total deck cards do I have? 52. Now on the second card, or when I draw the second card, how many cards are left in the deck when I draw that first one? All those 51, how many of them are 3s? 4. What are you going to notice about the answers here? They're going to be the same. Good. So they're going to be the same. It's the same numbers. So you could put 16 divided by, or you could do the reduced fraction. I'm taking a chance and seeing if they'll accept that. Find the probability of drawing a 10 and a 3 on either order. So there's two ways you could draw a 10 and a 3. What ways could I draw a 10 and a 3? Don't think too hard. What could I draw first? 3, and then I could draw what next? What's the other way I can get a 10 and a 3? 10 first and a 3 second. So these are my two possible outcomes, right? What do you think I would need to do with these to figure out the probability of getting a 10 and a 3 in either order? What could I do? So 10 and a 3. These are the two possible outcomes. So what I'm going to do is, all I have to do is just add these two together. So these are the two possible ways that could happen. So just add those together. And so you'll add those together. And so when you add them together, the denominator stays the same. Oops. And then the numerator just means 32 over. So you're just adding up okay, so 32 divided by 2652. I'm just taking a chance. Normally I would put the reduced fraction. I'm just trying to see if they'll accept it like that. Okay. Yeah.
Has it been in the announcements of it?
Let's look at number 6. We've got a recent study gave the information about the ages of children receiving toys. Percentages represent all the toys sold. So that means it's all the sample space. What's probably the toy is purchased by someone in the following age ranges? 6 and older. So 6 or older. 6 or older. So now or means you're going to do what? Add. Now, which ones are 6 or older? How would you classify that? Which groups are those? Yeah, exactly. We're looking at 6 and above, the bottom 3, right? So we're going to add those up. And they want percents here. So I'm just going to add that up. 27 plus 10 plus 30. So 67%. So they want percents here. Whoops. Computer's frozen a little bit. 12 or younger. So 12 years old or younger. So what am I adding here? 12 and below, right? So 12 and below. So 10 plus 27 plus 18 plus 15. 70. Between 6 and 12 years old. Between 6 and 12 years old. So what's between 6 and 12 years old? These two groups, 6 to 9 to 10 to 12. So 27 plus 10. 37. Between 3 and 9 years old. So between 3 and 9 years old. So 3 to 5, 6 to 9. So it's these two. 45. Oops, sorry about that. Lag here. All right, the children between 12 years old, look at this probability distribution. Ask, why are people more likely to buy toys for kids older than I am, 13 and over, than kids that are my age group, 10 to 12? How would you respond? So how would you respond to their thing? They're basically saying, why are people more likely to buy toys for the 13 and over group than the people in my age group, 10 to 12? How would you respond to that? What would be your response? The 13 older category may include children up to 17, 18 years old. That's a larger category, or that's include 17, 18 years old, and that's a smaller category. So what would be the better answer? Larger category. So basically, this is a larger category. This covers more ground. So that's why it's got more, because it covers more ground. You have, teenagers in there as well, or all the teenagers, 17, 18 in there as well. So, okay. Now onto the beast here, number 7, a little bit of one. This is the two-way table. So it's 7. In a sales effectiveness seminar, the group of sales representatives tried 2 approaches for selling a customer a new automobile: the aggressive approach and the passive approach. For 1,160 customers, the following record was kept. Suppose a customer selected at random from 1,160 customers. Let the following notation be event. A is the aggressive approach, P of A is passive, S is sale, N is no sale. So P of A is probably if an aggressive approach was used. What's the probability at P of S? So P of S is a probability that a sale was made. So a sale was made. So what you do here is you're going to go look how many sales were made. For me, it was 712 out of how many total? 1,160. Okay, they want this as fractions. So you probably could just leave this alone as an unreduced fraction. That can reduce, but you're kind of allowed to be sloppy there. The unreduced fraction shows all the possible outcomes. All right. P of S given A. This slash means given. So given A establishes your denominator. So your denominator will just be the aggressive total. The denominator will be the aggressive total. So the denominator is going to be the aggressive total. So the aggressive total, what's the aggressive total? For me, it's 580. So 580 is my aggressive total. Out of these 580 aggressive salesmen, how many of them made a sale? P of S means sale. So how many of them made a sale? So how many of them are in the sale category? 251. So 251. So you take this is your denominator. The aggressive total is your denominator. And then out of these 580, how many of them are also S? 251. So 251 divided by 580. Okay. P of S given PA. So P of S given PA. So given their passive approach, so PA, so this is going to be the passive total. So how many of them were passive salesmen? Okay, for me, I have 580. 580 were passive. Out of those 580, how many of these 580 made a sale? So how many of these 580 made a sale? 461. So 461 divided by 580. Are these events independent? So are the sale events, sale and passive approach, independent? So for these to be independent, here's what has to happen. The probability of sale has to equal the probability of sale given they took the passive approach. The probability of sale, so this probability has to equal the probability that they make a sale given they had a passive approach. So the question is, are these two equal? Well, we could try to look in our calculator at the decimals. One of them was 712 divided by 1,160. The other one was 461 divided by 580. Are these two proportions the same or close to the same? No, they're about 18% off. So that would be no. So no, because P of S does not equal P of S given PA. All right. Compute the probability of P, A, and S. So A and S, remember, that's a probability that they both happen at the same time. So like they both happen at the same time over the total. So P of A and S, I want to know first the probability that they're both aggressive and they made the sale. So what's probably how many are aggressive and made a sale? 251. All right. So you put that, the intersection of those two events, aggressive and sale, divided by the total, 1,160. So 251, 251. It looks like 261. 251 for me, divided by 1,160. So P, A, and S. So on this one, we want to know where the intersection of passive and sale. So passive and sale is 461. divided by the grand total, 1,160. Whoops, did not take my 4 in there. So you take the passive and sale intersection and you say, okay, let's look at another one, the probability of n. So P of n, call means probability of not making a sale. Probability of n is the probability of no sale. So I'm going to look at how many were not sold, 448 over the total, 1,160. So P of n is the number of no sales divided by the total. So 448 divided by 1,160. All right, this next one means P of n given A. So what's my denominator? My denominator is the aggressive. So my denominator is the aggressive total. So I just care about the aggressive ones. So I'm going to go back up here. And my aggressive ones are 580. Okay, so 580 is my aggressive. Out of these 580 aggressive ones, how many of them did not make a sale? So how many of these did not make a sale? 329. So 329 divided by 580. I don't need to put it. I can just put the unreduced fraction there. Okay, so I'm going to see if these are, I got to see if these are equal to be independent. P of n's got to equal P of n given A. So 448 divided by 1,160, 329. 329 divided by 1,001 or 580. Those are still about 18% off. That's not good. So it's not independent. What that means is that the style of sale impacts whether you make a sale or not. So whether you take a passive or aggressive approach, that's going to impact whether you make a sale. So it's going to matter. Compute the probability of A or S. So A or S, what I'm going to do is, or is a what word? Addition. So I'm going to get the total for aggressive. Total for aggressive is 580 plus the total for sales, 712. And there's an issue with this. I'll put over the grand total. I've got 580 here, aggressive, and then sales 712. And then from this group, what do I need to do? I have to subtract the overlap. I have to subtract the aggressive sale because that group's counting there and there. I only want to count it once. I'm going to subtract 251. So 580 plus 712 minus 251, 1,041 divided by 1,160. Okay. About 1,160. Hopefully. Oh, I made a mistake on that last one. I accidentally put an extra 1 there. I apologize. On that last one, I put an extra 1 on accident. Go back here. Double check your answers. The lag on my computer. I'm blaming the lag on my computer there. All right.